Hello, you're welcome to my YouTube channel. In this video, we're going to be solving this equation which says t raised to the power of 1 over 10 plus t raised to the power 1 over 15 plus t raised to the power 1 over 30 is equal to 84. Now, what are we going to do? Look at the exponent. This is 10 here, a denominator of 10. This is 15, this is 30. I want us to make all of them have a common denominator. If that is the case, I can now separate t and that common denominator. All right. If I'm able to separate t and the common denominator, then I can just make that t with the common denominator to be equal to another variable. And I will have a simplified equation. Now, let me tell you what I mean. So the LCM of 10, 15, and 30 is 30. So I'm going to write t raised to the power of what? 1 over 10. If you multiply by 3 because you want to get a common denominator, you must do the same thing to the numerator. Then plus, do the same thing here, 1 over 15. You multiply this by 2, multiply this by 2. We'll come to the last one. We already have it as 30, so we'll leave it like that. Okay. Now, this is t raised to the power of what? 3 over 30, because 3 times 1 is 3. Then, what about the next one? 2 over 30. T raised to the power of 1 over 30, and this is equal to 84. So, like I explained before, I am going to separate 3 over 30. Now, watch this. 3 over 30 can be written as 1 over 30 times 3. The same thing with 2 over 30. I'm going to rewrite it as 1 over 30 times 2. Okay, I'll show you why I'm doing this in a minute. So this will become t raised to the power of what? 1 over 30 times 3. All right, because 1 over 30 times 3 will still give you what? 3 over 30. Do the same thing here. T raised to the power of what? 1 over 30 times 2 plus t raised to the power of 1 over 30. And this is equal to 84. Okay, let me just separate this like this and like this. So what do you observe? We have t raised to the power 1 over 30, t raised to the power 1 over 30, t raised to the power 1 over 30 common for every term on the left-hand side. So I'm going to make that term, which is t raised to the power 1 over 30, be equal to, say, x. So I can say let x be equal to t raised to the power of 1 over 30. Now this is going to give me a simplified equation. So I have x, because I'm replacing this, raised to the power 3 plus, what about the next one? X raised to the power 2. It has a power of 2 here. And plus what? This is what? Just x. And all is equal to 84. Can you see how simplified this is now? So it will be easy for me to work this out. Now, I want you to look at 84 on the right-hand side. What will I make x to be equal to, so that when I add everything here, I'm going to have 84? If you start with, let's say 3 raised to the power 3, I'm making x 3, by the way, 3 raised to the power 2, then plus 3. Will this give me 84? 3 raised to the power 3 is what? 27. 3 raised to the power 2 is 9, and this is what? 3. This will give me 39, so it's not equal to 84. I want us to try it when x is equal to 4. So when x is equal to 4, let's see what that will give us. So 4 raised to the power 3 plus 4 raised to the power 2, and then plus 4. What is 4 raised to the power 3? That is 64. And what is 4 raised to the power 2? That is 16, then plus 4. 16 plus 4 is 20. 20 plus 64 is 84. So I'm going to rewrite 84 as what? 4 cubed plus 4 squared plus 4. So next line, I'm going to have x cubed plus x squared plus x is equal to 4 cubed plus 4 squared plus 4. Now, the reason why I decided to write it like that, because I want it to match in every way. All right, so that I will now use algebraic identities to work it out eventually. So I'm going to bring all these terms to the left-hand side. So I will have x raised to the power 3. If you bring this one over, you are going to have what? Minus 4 raised to the power 3. So plus x squared, if you bring 4 squared to the left hand side, you're going to have what? Minus 4 squared, and then plus x. If you bring plus 4 to the left hand side, you have minus 4, and this is equal to what? 0. Now I'm going to use algebraic identity here and here. Okay, so let's start with the first one. This is x cubed minus 4 cubed. If you have a raised to power 3 minus b raised to power 3, one of the algebraic identities, this will become a minus b, and then a squared plus ab plus b squared. So that's exactly what I'm going to be doing with this x cubed minus 4 cubed. So I'm going to have it like this, x minus 4. Notice I'm using this one to get it. And then what? X squared plus, this is ab, you multiply the two. So 4x plus 4x, and then plus what? This is b squared. So that will be what? 4 squared. So I'm going to write 4 squared here. Okay, and then the next one, this is difference of two squares. So this will be what? X minus 4, using difference of two squares, then x plus 4. And then we have the last term, which is what? X minus 4. I mean from here now. So all is equal to 0. So let's continue. Now, if you look at this term, and this term, and this term, what is common? X minus 4. So let's factor x minus 4 out. And then in bracket, I'm going to have, if you divide this first term by x minus 4, you are going to have what you have here. So that will be what? X squared plus 4x plus 4 squared is 16. So I can as well write 16, then plus, if you divide this by what we factored out, you are going to have what? X plus 4, and plus x minus 4 divided by x minus 4 will give you what? 1. So I write 1 here. And all is equal to what? 0. So let's simplify what we have in this bracket. So I'm going to have x minus 4, and then this is x squared. So let's start with x squared. 4x plus x is what? 5x. And then what is this? 16 plus 4 is 20, plus 1 is 21. So that's plus 21, and all is equal to what? 0. So I'm going to use 0 product rule here, because the product of these two factors is equal to 0. It means that either x minus 4 is equal to 0, or x squared plus 5x plus 21 is equal to 0. So if I take minus 4 to the right hand side here, I will have that x is equal to 4, or this other equation. But before we even go ahead to solve this equation, we need to test if the roots are real or imaginary. So if they are not real roots, there's no point moving further, because we cannot even use a complex root. Now, I want us to rewrite the equation x squared plus 5x plus 21. For me to test if this equation has real root or imaginary root, I'm going to use the discriminant d is equal to b squared minus 4ac. If what I have here is greater than 0, then the roots are real. Or if it is less than 0, then it is what? Imaginary. Okay, so let's quickly do a test. B squared, if you compare this quadratic equation with the general form, which is what? Ax squared plus bx plus c is equal to 0. We are comparing. You realize that what? A is equal to the coefficient of x squared, which is 1. B is the coefficient of x, which is 5. And c is what? 21. So c is 21. Okay. Testing this now using the discriminant, b squared minus 4ac. What is b? B is 5. So 5 squared minus 4ac. A is 1 and c is what? 21. So what is 5 squared? That's 25, minus 4 times 21 is what? 84. This is clearly less than 0. So this has complex solution, and we'll have to reject it because we cannot put it back into what we equated x to. We're not going to have any solution from there. So I'm only going to use the value of x equal to 4 to finish off this solution. So x is equal to what? 4 is the only value of x we are going to use. Now remember that x is equal to, let's quickly go back and check. What did we set s to? X is equal to, see it here, x is equal to what? T raised to the power of 1 over 30. T raised to the power of 1 over 30. Okay. So remember that x is equal to 4. So I'm going to plug in 4 here and equate this to t raised to the power of 1 over 30. Since I'm trying to get the value of t, I have to get rid of this power here. So what am I going to do? I am going to apply the 30th power to both sides. So that will be what? 4 raised to the power 30 is equal to t raised to the power 1 over 30, then raised to the power of what? 30. Now see the reason why I did this. 1 over 30 times 30 will give me what? 1. So when you cancel out, you just have t alone. So 4 raised to the power 30 is equal to t, and this is the value of t. Therefore, t is equal to 4 raised to the power 30. But hold on. Let's even get to the fun part where we'll have to test it back into the original equation. And let's see if when t is equal to 4 raised to the power 30, we're going to have what we have on the right hand side. So the original equation again is what? T raised to the power of 1 over 10 plus t raised to the power of 1 over 15 plus t raised to the power of what? 1 over 30. Let's see when we plug in 4 raised to the power 30 into this, we are going to have 84. So let's get started with this. T is what? 4 raised to the power 30. So 4 raised to the power 30 with a power of 1 over 10 plus 4 raised to the power 30 with an exponent of what? 1 over 15, then plus what? 4 raised to the power 30 with an exponent of what? 1 over 30. Notice I'm bringing all this one here and I'm substituting t for 4 raised to the power 30. So let's see if this will give us 84. Now notice 30 will cancel 30, and 15 into 30 is 2, 10 into 30 is 3. So I have 4 raised to the power 3 plus 4 raised to the power 2 plus 4. Okay, what's 4 raised to the power 3? That's 4 times 4 times 4, which is 64. And what is 4 raised to the power 2? That's what? 16. And this is 4. 16 plus 4 is 20. 20 plus 64 is 84. So we have it here as well that t truly is equal to 4 raised to the power of 30. I hope you enjoyed this video. If you did, kindly give this video a like and make sure you subscribe to this channel for more content like this. Do well also to share this video with your friends and family. I hope to see you in the next one. It is bye for now.